I hope you all enjoyed your weekend.
We moved to Ottawa?
Yeah.
Yeah, weird.
So let's see. Tomorrow, just so you know, no 2-hour delay. So you can sleep in a little bit if you haven't heard already. Last week we were talking about trigonometry. So trigonometry involved what type of triangles? What were you? Right triangles. We had that right triangles. What were our 3 trig ratios we have?
Sine,
Cosine, tangent. We had our little SOHCAHTOA to help us remember. What were we using trigonometry to help us find? Missing sides for special or non-special right triangles. Good. So triangles that we didn't have enough information for. We only had an angle. We only had the side. We were looking for any other side. Good. All right. So your warm-up is on the board. What do you notice is wrong with this problem? What is the mistake that this person did?
They didn't cross multiply. No, they got the sin ratio.
So they do essentially cross multiply. They just don't necessarily show the word. They multiply these 2 numbers, and then x would be multiplied by the other. So it doesn't work out. They do end up cross multiplying essentially. But if we look at the problem, they have opposite and adjacent are their 2 sides. But opposite and adjacent, that needs to be tangent, not sine. So it should have been the sine of 50 degrees equals x over 10. Now from here, what would you do in order to solve this problem? Find tan of 50. Okay. Get some calculators out. Get 4 kids.
Oh, not big calculators. Oh, graphic calculators. I was last year somebody typed I want death in the No. Yeah, Lily found survival death.
So if we plug in tangent of 50, what do we end up with?
$1.192.
1.192. That equals our x over 10. And once again, we can always put that over 1. And carry 1 to start cross multiplying. Good. That gives us x. And then 1.192 times 10 should be 11.9. That would be, are we okay with this from yesterday? Not yesterday, last week? I mean, I was serious. That was fun. I don't know. All right. I would think today. What do you see with this problem? Do you see a mistake?
Yeah, they, which thing? Did they cross multiply?
They do. So if you put this over 1. What's the mistake now?
There should be 28 over x.
Good. So if we look at it, they have hypotenuse and adjacent. That's correct. So they know they're going to need cosine. But the thing is, if we look at cosine, thinking through SOHCAHTOA, A comes before H. So adjacent needs to be above our hypotenuse. So it needs to be adjacent over hypotenuse. So rather than x over 28, cosine of 35 should be equal to 28 over x. And that's what they would need to do. So see if you can go through and find the answer to this one. Just a moment. So what do we find cosine of 35 to be? 819, that equals 28 over x. What did you do from here?
Over 1.
Okay. What does that give us?
28 equals 0.81
1.9x, and you have to divide. And then that gives you x equals 34.198.
Are we okay with this? So last week, this is what we focused on. We focused on solving these missing sides, focused on being able to find those missing pieces of our triangle. And so if you have this mastered, what we talk about today will be a breeze, and you'll probably fly through it.
With what we're doing.
What we're doing today. And so we know how to find missing sides. We know how to solve this. The thing that we don't know is what if we have two sides, but we don't know what the angle is?
Is it on my paper?
I don't think this picture is. I'm sorry. Yeah, that first part where I have all those things. But we don't know how to solve this yet. And so, thinking through this problem, based off of the sides given, what sides do we have?
Opposite.
We have opposite and adjacent. So if we were to think sort of backwards, we know that tangent of some unknown angle, this is equal to our opposite side of 3.5 over our adjacent side of 5. So if we figure out what 3.5 over 5 is, all we have to do is just check which tangent equals that value. So we could check, does tangent of 1 equal this? Does tangent of 2 equal this? Does tangent of 3 equal this? Does tangent of 4 equal this? That would take a while. So what they used to have is they would have a big sheet that would have all these tangents, cosines, sines. So angle 50, tangent is 1.192, sine is 0.766. And then, so you'd be able to see, okay, I have 1.732. So looking at that, that means my angle needs to be 60 degrees. And so they used to have these big sheets that you would have to flip through to be able to like circle and find your number. That's still a lot of work. We don't want to add to that.
I would like that. I like those.
Okay. Maybe I can find one and bring one in for you.
Really?
Maybe. I don't know if
You
they still
said
have
I
these.
would honestly, I would use that.
These are cool. But luckily on our calculator we have something that works like this. And so we have things called inverse trig ratios on our calculator. So if you look at your calculator, if you look at your sine, cosine, and tangent, in blue right above it is sine of -1, cosine of -1, cosine or tangent. These are your inverse ratios. So inverse sine, inverse cosine, inverse tangent. So in order to do them on the calculator, all you have to do is hit second, and then hit sine, or second cosine, second tangent, and it'll come up with the inverse. And the way these work is, thinking back to like our problem before, we're going to take that value that we set up, our typical opposite over adjacent, adjacent over hypotenuse, opposite over hypotenuse, and you're going to plug that into your inverse function, like where the angle used to be. So rather than having the angle in the function, we're going to, or in the ratio, you're going to plug in the sides, and then they'll give you the angle as the answer. So these are typically a lot easier than the other ones because we don't have to worry about cross multiplying or anything like that. All you have to do is make sure you have the right ratio, make sure you set up your sides correctly, and then the rest of it will be very, very simple. So let's look at an example. So we have these two problems. So seeing this one, we have 8 and 6.71. What sides do we have available to us on this problem? Opposite and adjacent. Opposite side, adjacent side. So based off of opposite and adjacent, I know I'm going to need to use tangent. So I'm going to have tangent, but because I'm looking for that missing angle, it's going to be an inverse tangent. I'm going to use inverse tangent. Tangent I know is opposite over adjacent. So my opposite side is 8. My tangent or my adjacent side is 6.71. All I have to do is plug 8 over 6.71, and I can plug this whole thing directly into the calculator and just type this whole thing in there. So inverse tangent of 8 divided by 6.71, close my parenthesis.
50.012.
50.01 or whatever, 2 or whatever the number comes out to be. But that is your angle you get for your problem. So these are very, very simple. Just set up, make sure you know what side you need to use. Make sure you know how the ratios work. We learned that last week though, so all of the hard stuff we learned before. All you have to do is really just use that inverse and then use it. So looking at the second problem, based off of our angle, once again, what sides do we have? Adjacent and opposite once again. So once again, we're going to use our tangent, so inverse tangent of opposite over adjacent, 42.89 over 20. Plug it right in, see what we get. We end up with 65.04.
What?
65.05.
I have 64.9.
See, I probably hit one. I did. How many changes?
Is it 20 or 21?
20.
Why didn't you even ask me? I got 64.99.
64.9. Yeah. I switched two numbers. Thank you for catching that.
Do I have to round it out?
So you could round up to 65.9 or 65.00 if you wanted to round because it's very, very close to 65. You don't have to round as long as you're within 1 or 2 decimal places.
Amanda's too scared to round for this because to get outside.
Well, no one else does. Mine
No, you're not. So if you wanted to put that at 65.00 rather than 64.999 or something like that.
Calculator's broken. None of the answers are like at all. No, calculator's broken. I said we have to.
So if it's ever giving you weird numbers like that, go hit mode, come up, and see yours in the gradient degrees.
Oh.
So it's reading.
Okay,
So if these calculators get reset, they just automatically change. That's why they sometimes come up. So I have to like manually go through and use, or sometimes they use radians in Calc 2, or in Algebra 2 they'll use radians, and so you sometimes you just have to watch. Yeah. Well, we should have gotten 64.999 or 65 degrees. So these are very simple once again. Plug in the value, set up your ratios, hit the buttons all in the calculator, and it's good to go. Mainly the calculator is the majority of the work. We just have to set it up. And so as long as you were good with last week, this stuff should be very simple for you. One other thing we'll talk about. So there's a Greek letter theta.
Oh gosh.
It looks like a circle with like a dash through it. This is the normal variable that people use to represent a physics angle. So on your state test, you might see a triangle. Right triangle, pretend it's right triangle, and you might see that Greek letter theta in there, and then you have like 4.6 and then h or whatever, and you would have to solve for theta. What was that? But yeah, so theta is just a variable, just like x, just like y. It's just a Greek letter, so it looks a little different. But don't let theta alarm you if it comes up. It's just a variable. It's just representing which angle you need to solve for. Trying to think if there's anything else.
Will always be an angle and put the side.
Typically theta is reserved for angles. It's possible, because it is a variable, it's possible that they could throw it in for a side, but almost always theta is reserved for angles. They will probably throw an X or Y or some other letter in for missing sides. So see if you can practice this. I don't think it will take you the whole time. I don't think it will take you very long. You'll probably get used to it. You'll probably be able to think through them pretty quickly. But see if you can practice finding the angles using this trick, just like what we did on this first one.